Hello, I welcome you all. The problem reads the 5 megagrams truck and the 2 megagrams car traveling with the free roaring velocities shown just below they collide. After the collision, the car moves with a velocity of 15 kilometers per hour to the right relative to the truck. Determine the coefficient of restitution between the truck and the car and the loss of energy due to collision. This problem is coming from the Engineering Mechanics and Dynamics, a 14th edition by RC Benam. So we are dealing with what we are calling impact, and this occurs when two objects collide with each other over a short period of time. Okay, and this as a result creates relatively large impulsive forces that interact between these particular objects. All right, an example is striking a hammer on the nail, okay, or striking a golf ball with a golf club. That creates what are called impact loading. So here we have two cars that are rolling, okay, freely rolling. So we are going to call this car T, just call T, and this one we call C. So here we've been told that, and this one we call it VT is, and then this one is VC, like so. And then the mass of this truck is equal to 5,000 kgs. Okay, right? And then the mass of this car is equal to 2,000 kgs. All right. So if we converted this to meters per second, then we have 30,000. This is what you can do on your own, divided by 3,600. So this just becomes 8.33 meters per second. All right. So 30,000 divided by second 3,600, 8.33. And if we converted this also, that's 10,000 divided by 3,600. This gives us a 2.78 meters per second. All right. So what are we being asked here to do? To determine the coefficient of restitution E equal to, so we have E equal to VC2 minus VT2 and divided by VT1 minus VC1. All right. So basically, this is what we want to find. Great. So then, so using the conservation of momentum, because as a system of particles, momentum is going to be conserved. So using the conservation of momentum principle, which will be conserved, we know that mt vt1 plus mc vc1 is just equal to mt vt2 plus mc vc2. Right. Then we do have the information for all of them. You can just replug them. So we said mt is a 5,000 all right, by VT1, okay, just 8.33, okay, plus MC is 2000 by VC, which is 2.78, like so. Then this is just going to be equal to 5000 by VC2 plus 2000 by VC2. Right, so let's write this equation. Let's work it out. So we have 5000 by 8.33 plus 2000 by 2.78. This gives us a 47 210 equal to 5000 VT2 plus 2000 VC2, and this is our equation 1. So having found this, we need another equation. Which we need to use to work out the other part. I mean, we have two unknowns, so let me just move this line somewhere there like so. All right, so we need another equation. So then we've been told that after the collision, after the collision, the velocity of the car relative to the track, which is also written as VC2. 2 just simply means this subscript 2 just simply means that this is considering after the collision. And VT2, this is equal to 15 kilometers per hour. And if we converted this to meters, then it becomes 15,000 divided by 3,600. And this is just a 4.17, okay, meters per second. Therefore, VC2 minus VT2 is just equal to 4.17, and this is our equation 2. So solving these two equations, I'll just make VC there, VC2 subject to the formula, is equal to 4.17 plus VT2, and then bringing in that equation, 47 to 10, this is equal to 5000 VT2 plus 2000 VC2 is 4.17 plus VT2. Therefore, if we worked out this, let me just create a bit of a boundary here. Okay, right. So if we worked on this, then we'll have our VT2 equal to, you can get your calculator and do this directly. So we have 5,000 plus 2,000, 7,000, then we have 47 to 10 minus 2000 by 4.17. Okay, then divided by answer. So this gives us a 5.55 meters per second, right? So 47 to 10 minus 2000, 4.17, then divided by 7,000. All right, and this velocity is going to this direction. And then we do have VC2 This is just going to be equal to 4.55 plus 4.17, so 5.55 plus 4.17. This gives us a 9.72 meters per second. This goes in this direction. So the question here is to determine the coefficient of restitution. So we know that E is just equal to Vc2 minus Vt2 divided by Vt1 minus Vc1, like so. Right. So our E therefore is just going to be equal to Vc2 is a 9.72, Vt2 is 5.55, and Vt1 is 8.33, and then the other one is 2.78. Therefore, our E, if we calculated that, so we have 9.72 minus 5.55 divided by 8.33 minus 2.78. So this gives us a 0.7513. Okay, like so. So the other part is to determine the loss of energy. So we know that loss of energy from position 1 to position 2 is just equal to the difference in the kinetic energy. Okay, T1. Okay, which is just equal to summation of half m v2 squared minus summation of half m v1 squared. Right, so what do we have? So we do have this is equal to this summation of, the loss of energy is just equal to half there. So we do have 5,000 for the track by 5.55 squared plus half 2,000 by 9 by 72 squared minus half by 5,000 8.33 squared plus half 2,000 by 2.78. Okay, and then the loss in energy from 1 to 2, this is just going to be equal to so 0.5 by 5,000 by 5.55 squared plus 0.5 by 2,000 by 9.72 squared, close brackets, 0.5 by 5,000 by 8.33 squared plus 0.5 by 2,000 by 2.78 squared. So this difference gives us a minus 9,700 9797. So this is minus 9716. This is joules or Newton meters. So this is the loss in energy. So 0.5 by 5,000 by 5.55 squared plus 0.5 by 2,000 by 9.72 squared minus 0.5 by 5,000 by 8.33 squared plus 0.5 by 2,000 by 2.78 squared. So 9716. So I think this is really about it. So we do have these velocities after the collision. We do have the coefficient of restitution. We do have the loss of energy there, which is equal to 9,716 joules. I think this is about it, and I hope this video is helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.